Greetings to all. Today's topic is common channel signaling. Common channel signaling in the sense it describes about the transmission of control channels. Common channel signaling doesn't mean that it uses the common channel for data and transmission signals, transmission of control signals. It is a kind of out of band signaling. Signaling, as I informed, signaling is nothing but it is a basic concept in the communication which is used to transfer the control and management signals. What may be the control signals? The call establishment signals, like whether the mobile is free or mobile network is free, and mobile is ready to accept, user terminal is ready to accept any communications. That is called as control signals or control data. And the management signals are nothing but about the what type of data is transferred, uh, what is the location of the user equipment. All this comes under the management is to give whether it is a roaming call or what about the bill, all these datas which base station will be used. These all comes under the management signals. And control signals are used to call setup and call termination. So this kind of signaling can be divided into two things. One is called as in-band signaling, another is the out-of-band signaling. In-band signaling is nothing but signaling is nothing but uses the common channel or same channel for both the transmission of data as well as control. That is, in in-band signaling, data and control signals are transferred through a same channel. Whereas in the out-of-band signaling, data and control signals are uses a separate channels. This is called out of band signaling. Common channel signaling comes under out of band signaling. It has the dedicated channels for control signals. The control signals are termed here as a signaling, and the speech is nothing but the example of your data. Signaling is nothing but for the voice signal. So two different channels are used. One is dedicatively used for transferring the data signal. Another is for control signals. So this is called common channel signal. It is a fundamental approach in the wireless and cellular networks. This is the block diagram for the common channel signaling. SMS is nothing but service management system. This service management systems are connecting all the endpoints. Oh, sorry, all the endpoints. Service management systems are used the all the endpoints, service endpoints. So SCPs are nothing but switching endpoints. The switching endpoints are connected to the MSEs as well as the UEs. That is, UEs are nothing but the user equipments. SS7 is the protocol used for transferring the control data. Transferring the control data between SCP to STP or between two signal transfer points. STPs are nothing but signal transfer points. Between two signal transfer points or transferring between SCPs to signal transfer points, a kind of guidelines are used. That is given here as a protocol stack. SS7 is a protocol stack which is commonly used in CCS. So the description of each point is given here. SCP is nothing but switching endpoints. That's nothing but the end nodes. Examples: mobile switching centers or other switches. These all comes under the switching end nodes. STPs are transfer points. They receive, process, forward the signaling messages between the SCPs or between SCP to STP. All those things. SMS is nothing but service management system which provide the service control and database functions such as subscriber information lookups and location data, all those things. MSCs are the endpoints, mobile switching centers, which can be communicated to one base station to other base station through MSCs, or the MSCs will be used to transfer the data from one location, that is one MSC to other MSC, all those things. So let us look at the key aspects of common channel signaling. As I informed earlier, the first thing is it has a dedicated signaling channel. CCS is nothing but you have dedicated separate channel for transferring the control signals. Control signals are nothing but a call data like a call termination, call setup, or any management functions like user location. All those things comes under the management data. This allows control messages to be exchanged independently, which is essential for maintaining the efficient communication. Since separate channels are allocated for the control signals, the data flow is independent with respect to voice or other data. Second aspect is type of signaling channels. We have SS7, it's nothing but signaling system number 7, which will be widely used in CCS protocols. This is used in second generation communications, that is GSM. Other type of signaling protocols are packet switched signaling in IP networks. This is primarily for internet protocol networks, IP based networks, where the packet switchings are enabled through this packet switching signaling protocols. It's called as SIP, Session Initiation Protocols. Radio Resource Control Protocol (RRC). This is used in all kind of advanced communication systems like LTE and 5G. The functions and advantages are functions, as I mentioned, signaling is nothing but transferring the control signals. So it is used to control, that is used to do the call setup and the call termination. When there is a handoff, all the control signals has to be transferred from one base station to another base station. This is called handover control. That is also done with the common channel signaling. The third one is management, where the mobile location updates are done in the mobility management. The fourth one is network management and maintenance, diagnosis of network. Whether the network is good or one STP is not functioning, it will go for the another network. It will be setting the networks through the CCS signals. As I mentioned, GSM is especially used for SS7 protocols, and LTE and 5G are the other examples which are used the common channel signaling. The RRC protocols are used for the advanced communication systems. The key benefits of the common channel signaling are it increases the efficiency. As I mentioned, a separate channel is used for control signals. Dedicated channels are used for the data communications. So the control signal transmission will not affect the data communications, hence efficiency will be improved. And the scalability, we can increase the number of nodes in the networks that will not affect, hence the separate channels can be used for the control signals. That is called scalability. Reliability, a dedicated channel gives the reliability. The speed of call setup, termination and handovers will be significantly high. That is given by the reliability. Hacking is also very less, so that the security is maintained. Hackers normally aims at the data channels, not the control channels. So the data, the control, or that is the user data will be information about the user equipment will be safe. That is given by security. Challenges: the resource allocation. We need a separate channel for the control channels. That is a little difficult while we are doing the spectrum allocation. That is, it requires a separate resource. That is the big challenge compared to the all other advantages. Another is when we go for the packet switching, there will be some latency observed due to the call setup and other informations. The call setup and others are done by the control channels. Once it is completed, the call setup is completed, the data is going to be transmitted. In packet switching, the latency is observed due to the separate setting up of the call. And there is complexity. As we mentioned, it requires separate protocols like SS7, RRC, all those things. Hence, the complexity of this is increased. That's all about the common channel signaling. Thank you.